In this lecture, we're going to learn about explicit constructors. And to really drive the point home, we're going to look at a simple example. Here is a class which is called square. It is going to be modeling a square. So we're going to use a member variable which is going to represent the size of our square, and we can use this. Then we're going to have a function which is going to compute the surface of this square here, and it is going to be a const member function. This function is really simple, and there is really nothing more one can say about this. Let's look at how we can implement the functions we have in. We could implement our constructor using an initializer list like this. So we're going to take the side member variable and we're going to initialize this with our side param. Then we're going to compute the surface. The surface is going to basically be side multiplied by side. And then we're going to return this. And whoever called this surface function on our class object is going to be able to use the return value here. The destructor is going to be empty. It's basically going to do nothing. It's just going to be in there. So this is how we could set up our square class. Okay, so suppose we have our square class like we have seen, and we set up a function which is going to compare two squares. So we have the compare function here, and it's going to take two square parameters by const reference because we don't want to be copying squares here, and we just want to use the original values and read from them and do some computation in the body here. In the body, you see that we are comparing the surfaces for the squares. So we are basically saying if the surface of square 1 is greater, then we're going to consider that as the greater square. And then if the surface of square 2 is greater, we're going to consider that as the greater square. So what the function here will be doing is checking if square 1 is greater than square 2. So what we have in the first position here is going to be compared to what we have in position 2 here. And in the body, what we're going to say is ask if the surface of square 1 is greater than the surface of square 2 here. If that's true, we're going to return true. If it's not true, we're going to return false. This is what the function here is doing. So once we have the function here, we can call it in the main function. We're going to have two squares, square 1 and square 2, and we can compare them like we do here. But the problem is going to come if we use arguments that may involve implicit conversions. And look at the example we have here. We are basically comparing square 1 with 45.5, which is a double literal here. When we issue a call like this, the compiler is going to say that the second parameter to this function is really a square. And it's going to ask itself, can I do an implicit conversion from this argument I have here to a square? And the fact is, it can because our constructor is only taking one parameter. So what the compiler is going to do is convert this guy into a square object, and then it is going to compare these two square objects. And if these implicit conversions are what you want, this is going to be fine. But sometimes the caller of this function will really want to compare a square to a number. So they want to take the square one and compare that to 44.5, if this makes sense for whatever you are doing in your application. And in that case, implicit conversions are not going to be what you want, and you're going to get wrong results. If you don't want these implicit conversions, it is possible to mark your constructor as explicit. And what this tells the compiler is to never use this constructor in implicit conversions. So if we have this constructor here and it is explicit, and we try to issue a call like this, we're going to get a compiler error because the constructor for our square object can never be used in implicit conversions. And what we are doing here is really going to set up implicit conversions. So you can use explicit constructors if you don't want your constructor to be involved in implicit conversions that are done by the compiler. Okay, I really hope you understand this. So we may also fall in the same case if we have a constructor which doesn't take only one parameters, but we have a single parameter which is not using a default parameter. Let's show you what I mean here. Here we have our side param, but we have a second parameter which is specified by default. So if we have this setup and we have the same call we have in the main function with the second parameter set up as 44.5, the compiler is going to see that it can still use this constructor to do implicit conversions from a number to this square object here. And it's going to also use this constructor. So if we don't want implicit conversions, we can also mark this constructor as an explicit constructor, and it is going to be prevented from being used in implicit conversions. This can be confusing, and if you still don't really understand this, please bear with me. We're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is Explicit Constructors. We're going to use our template files here, so let's grab them. And we're going to paste them in place. And we're going to open this little guy in Visual Studio Code by dragging and dropping here. This is going to open our folder. We're going to have our main function. And we need to create our square class because we want to play with it in here. So what we're going to do is create the header file and the CPP file for that. Let's do square.h for the header, and we're going to add a new file for square.cpp. This is done. And we are going to head in our header file and put in our class. So we don't want to type this. I am just going to put it in here. Then we're going to explain it a little bit. We have our include guards, and then we have our class which is declared and defined here. We have two sections in the class. We have a public section and we have a private section. In our private section, we have our member variable, which is declared to be mside. Its type is double. And in the public section, we're going to have a constructor, which is going to take one parameter. We have a destructor, which is going to destroy our object. And we have a function, which is going to compute our surface here. Nothing special here so far. We are going to head in square.cpp and put in the implementation for our class. So we have the implementation for the constructor. It is going to be using initializer list. You see the syntax here. We have our column, we have our member variable, and we are using curly braces to do that. So you can use curly braces with your initializer lists. This is going to work. Down here, you see we have the surface function. It is a const member function. We need to specify that here. And it is basically going to return mside multiplied by mside because that's going to be the surface. And the destructor is really not doing anything, so it is going to be empty here, but we're going to leave this in. Okay, so now that we have this little guy here, let's head over to the main function and play with it. So we're going to close the left sidebar here because we don't need it anymore. We're going to take out whatever we don't need in the main CPP file. We're going to include our square class. We can do that. And then we're going to put in the function which is going to compare two squares. We have the function called compare. It's going to compare square 1 and square 2. The parameters are passed by const reference because we don't want to copy our square objects. We just want to read data from them, compare them, and return the result. So we're going to ask, is the surface of square 1 greater than the surface of square 2? That's what this function here is doing. If square 1 is greater than 2 in terms of surface, we're going to return true. If square 1 is not greater, we're going to return false. That's what we are doing here. So we can set up two square objects and try this function here. We're going to say square, and we're going to call this S1. We're going to put in a 10.0, and we're going to do a second one. This one is going to be S2, and we're going to put in a 20.0. You already know which one is greater. So we're going to try and use our function here and see that it is actually working. We're going to say S1 greater than S2. And we're going to do that using the call here, compare S1 to S2. We're going to be passing this by reference, by the way. And we want the output to be in the form of true and false. So we're going to put our bool alpha manipulator here. So we're going to say std cout std bool alpha. And we're going to build and run this program. We expect to see a false because the surface of square 1 is really not going to be greater than the surface of square 2 here. So we're going to see a false printed out here. Let's build. We're going to bring up a terminal, and then we're going to use the task to build with GCC. This is going to build fine. We can clear and run rooster. And we're going to see that square 1 is not greater than square 2. This is what we expect. We can change the side of square 1 to be 100 and build again and really see that our function is doing what we want. We're going to clear. The build is good, by the way. We can clear and run rooster. Now we're going to see that square 1 is greater than square 2 because its surface is definitely going to be greater than that of square 2 here. This is working, but we may have problems if we set up a call that involves implicit conversions. So let's do a call in which we want to compare square 1 to a double literal. We can do that. So we're going to put our stdc out statement here, and we want to see if square 1 is greater than 45.9, for example. We can do this. So we're going to put 45.9 here, and notice that we don't have a squiggly line or any problem. And if we go back to our compare function, you see that we don't have any overload that takes the second parameter as a double. So the compiler is going to look at the call here, and it's going to say, let me see if I can use a second parameter as a double here. And it's going to say, I cannot do that because the second parameter is a square object. The compiler isn't going to give up easily. So it's going to say, I can't use a double argument for the second parameter here directly, but it's going to ask, is it possible that I can convert from this double to a square object? And it's going to look at the constructors we have in here. It's going to see, I have one constructor which is going to take a double parameter. I can use this and convert from this double argument I have here to a square object. And the compiler is going to do that and create a temporary somewhere which is going to be a square object, and it is going to pass that square object in this function here and do the comparison, and then it's going to throw the temporary away and it's going to give you the result. So what we will be doing here is really comparing two squares. One square whose side is 100 and another whose side is 45.9. And this can really be hard to see because what you see here is a number, and you might think that the compiler is really comparing square 1 to a number, but it is going to be comparing two squares because it inserted an implicit conversion from this double here to a square. If this is what you want, we're going to see that this is going to compare two squares, and we're going to see our output in a minute. So let's do that. We're going to build this with GCC so that you see that this is going to build without a problem. The build is good, and we can see our output here. We're going to run rooster, and we're going to see that square 1 is actually greater than 45.9 because square 1 has a side which is 100, and square 2 is going to be having a side of 45.9 here. But we have an implicit conversion, and sometimes this is not what we want. So if we don't want these implicit conversions, we can mark our constructor as explicit. And what this tells the compiler is don't use my constructor here in implicit conversions. If somebody wants to use my constructor here, they have to call it explicitly like they have created an object here and then use that object to call the compare function. So we can do that using the explicit keyword like we see here. So if we mark this constructor as explicit, we're going to see that at this line now, we're going to have a squiggly line because the compiler is not allowed to insert an implicit conversion from double to our square object using our constructor here. So if we use this, now we're going to get a compiler error. You see Visual Studio Code already has a problem. If we look at the problems tab here, we're going to see no suitable constructor exists to convert from double to square. And this is a hint that the compiler is actually trying to convert from double to square. And we have disallowed that or prevented that through the explicit keyword here. And this is really cool. So we can build with GCC and see the compiler error. We're going to see that the compiler error is going to say invalid initialization of reference const square. The second parameter couldn't be initialized properly. So the second thing here is not going to work. And it's going to basically say, I can't really figure out how to use a double argument and compare that as we are doing in the compare function here. So you're going to get a compiler error, and this is good if you don't want your constructor involved in implicit conversions. We may also face the same problem if we are using default arguments. And I am going to show you that here. We're going to include the string object, the string class I should say, and we're going to set up a second member variable in our class, which is going to be of std string type, and we're going to say mColor. This is going to be the color of our square. We might model our square like this and give it a color, and we're going to specify a second parameter to the constructor, which is going to initialize our member variable with the default parameter. So if we do something like this, we might say const std string reference, and then we're going to say color param. We can save that, and we're going to set this to black, for example. Let's say our square is going to be black by default, and we need to specify the second parameter in our implementation in the CPP file. So let's copy that, and we're going to put that in place here, and this is right, and we need to put our initializer list to the second line, and then we're going to put in another line which is going to initialize our color. So we're going to take the color and initialize this with color param. Okay, we can do this, and you're going to see that the compiler is going to take this because we are just initializing our member variables using this initializer lists. But what we want to see is that even if you have a lot of parameters, but the first one isn't using a default parameter and the other ones are going to be using a default parameter, this can also be used in implicit conversions, and the compiler might pick this up to convert from a double to a square object. Because it's just going to use that double for the first parameter, and for the others it's going to use the defaults. So we can also protect this and make this explicit, and the compiler is not going to use it in implicit conversions. And now if we build, we're going to get the same error we had. We're going to build with GCC, and we are basically going to be told the compiler can't use this constructor in implicit conversions because it is explicit. And this is really all explicit constructors are all about. You mark your constructor explicit if you don't want it involved in implicit conversions that are done by the compiler. So this is all for this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to learn about copy constructors. Go ahead and finish up here and meet me there.